Welcome to Warrior. This is the next episode of a really exciting series where Warrior is partnering with UAS Hub. They are a portion of SAE Media, a UK-based think tank. They're counter drone specialists. We are hearing from the best and brightest. We've got one right here, Mr. Jeff Cole. He is the founder and CEO of an interesting firm called Hidden Level. And what they do is have a radar that essentially blankets everywhere. It's optimal for counter drone, even has potential Golden Dome applications. Let's welcome our superstar expert and let's get right to what their technology offering is. We should tell you for context, they support Army vehicle convoys, they support the U.S. Air Force. This technology is already operational and still being upgraded. Mr. Cole, thanks for being here.
Chris, thank you for having me. I love it. Thank you.
Excellent. Well, tell us just in a general sense to start with what your technology is and what it does. And you mentioned it's now currently protecting Army convoys as well as some Air Force technologies. Give us a quick overview.
Yeah, Hidden Level, we're a vertically integrated company. We specialize in passive radar and RF detection. So we develop everything in-house from antenna arrays to all the software-defined radio, embedded software firmware, everything mechanically in-house. And we sell technology as commercial off-the-shelf modified COTS direct to the Department of War and the consumers there, and also to foreign ministries of defense. And then we also own an infrastructure, kind of like a telco, of the technology in which we have developed to provide an air surveillance picture as a service. So that allows you to see everything from small non-cooperative drones to non-cooperative manned aircraft, fighters, and stratospheric balloons. So think of everything from 70,000 feet and below. We have the ability to help people find it for national security concerns, but then also to help enable the airspace and the airways for things like drone delivery, flying more people through the skies safely. That's in the realm in which we play.
10-4. Well, let's talk a little bit about the technical mechanisms that makes this possible or enables this. You mentioned cell towers. I would imagine there's also some satellite connectivity. How are these sort of pervasive or ubiquitous eyes kind of accomplished in a technical sense?
Yeah, so in two ways. In our infrastructure, we deploy onto existing infrastructure that's there. Thank you to the cell industry and wireless industry. There's towers and rooftop availability all over the world. So we co-locate on rooftop cell towers and then hook into existing backhaul, whether that's satellite communications, cellular, fiber. It's a very lightweight backhaul request that then makes our air surveillance picture as a service available to everything from state and local users, enterprise Fortune 500 to United States government or other government customers. The hardware we sell that's deployed on convoys around the world, that integrates directly into existing systems. This is a key thing recently. If you listen to Alex Miller, the CTO of the Army, interoperability is fundamental. So technology that can hook into existing technology, whether it's command and control, countermeasures, other sensing technologies, interoperability is fundamental in enabling the warfighter for safe operation.
Excellent. We could talk for hours about this. Fantastic expertise. Well, let's put this in an operational context because you currently protect Army vehicles. Let's say a convoy, a mechanized formation is moving to contact. There's a handful of small drones, or heaven forbid, a drone swarm on the other side of a mountain. This has the ability to detect that. So, what can this do in real time? And what is the resolution? Because I imagine you have very high fidelity if you can see small drones pretty much across the board.
Yeah, the challenge we set out to solve was there's a lot of great systems out there, a lot of active radar systems, other types of systems. The downside to those systems was when you're active, people know where you are. You're emitting RF energy, so people can
Right.
detect that. And we were seeing that play out in Ukraine. We said rather than replace all those systems, how can we give a capability that can hook onto those systems, piggyback off of it, or allow convoys or forward operating bases to operate silently? So that is the breakthrough is passive radar technology. So it means we're able to put our sensors on the vehicles and around forward operating bases. We don't emit a signal. We use signals from other sources to illuminate. That's where you get the radar part to see everything from small drones to ground vehicles, large airborne flying things. And the fidelity in which we're able to do that and positioning of both an elevation and azimuth allows the end user to start the kill chain. So we queue systems like crows and other systems that exist. This is the interoperability. The customer said, hey, these are the things I have right now. I need you to be able to hook into those and effectively give us what we need to get on target. And that is what we were able to do. So now you have a convoy that's operating. It's not emitting any signals. There's signals being operated and sent out from other systems around the area. Both could be adversarial, could be our own, but we use those to illuminate the air and the ground so that we can see other things around us and make determinations on what we call sense, make sense, and decide. And then to decide is the key in the interoperability. That's got to hook into those systems and allow them to.
So could you explain us to through how this would work in, say, an operational context?
Yeah. So in a forward deployed convoy, whether it's a vehicle or a base, there are other signals that are out there. They could be high powered radar systems that are deployed elsewhere, comms networks. It could be other types of signals, or you can introduce signals into the environment, but you keep them away from the valuable asset, the human beings or something you want to protect. So that's the beauty with passive radar. You have the ability to separate the transmitter, the thing that people know is there, and the receiver. And we can piggyback if there's systems out there that are sending out energy, we'll use it. Or we can introduce energy, but we keep it away from the asset we're trying to protect, whether that's a base, a vehicle, a formation, a group of soldiers. That is how the technology works. And when we're in an urban environment like the United States, there's all kind of energy already there. You've got or places around the world, you got all kinds of energy because there's comm systems, there's all kinds of weather radars, air surveillance radars, all these systems that are already sending out energy. And then we are able to use that energy to fill in the gaps. So we can see down
Excellent.
low and look up high. We expand the coverage. So think of us as bolting on to existing systems and expanding the coverage.
Excellent. Well, let's talk a little bit about PED, processing, exploitation, dissemination, this whole challenge of aggregating information, processing it at a point of collection, and networking it. How are these different nodes? Because I imagine if you're using an existing apparatus to an extent, how are they networked one another to get that common picture and pass off threat track data?
Yeah. So again, key is interoperability. Work with what you have. So in our infrastructure, when we deploy it here in the US, we can use satellite systems, we can use cellular, we can use fiber. And then now those systems are all connected, and then we're able to provide access via basic API into existing networks, whether that's using systems that are out there like C2s that exist, FAA infrastructure, Department of Homeland Security, the cops that the state and local use, et cetera, hooking into their existing picture allows them to already integrate our data with other data feeds that they have to make decisions quickly. When we're forward deployed, we have to be flexible and nimble. We may be on a point-to-point comms network. We may be on whatever's available, satellite, Starlink, stuff like that. Lightweight, interoperable, again, allowing either the user to give it all its decision at its point, the vehicle or the fob, or being able to share information between vehicles and different fobs via satellite communications. Interoperability, though, is fundamental. You just got to work with what's already there.
Excellent. Well, give us a quick look because we'll do a second episode where we'll talk about potential Golden Dome applications because this seems very optimal for that kind of echelon to echelon connectivity. For now, can you? I understand you can pull up a graphic and give us an
Yeah.
idea of the fidelity and the way in which this works. And then, yes, go ahead. Let's do that.
Yeah. So this is real time right now. This is some of our deployments in the United States. This is kind of the commercial view. And you've got everything from different types of planes, helicopters, and drones. Here's in California right now. This is real time. This is right outside of Moffett Field, Ames. So you've got this drone here is we're detecting the signal it's emitting off of it and also the controller signal. And then we're also picking up its license plate, its remote ID. So that's how it had the star there. That's letting you know that this is also a remote ID enabled craft. So this is providing as much information as we can around the craft and what's going on. so that people can make decisions. Make sense, decide. Is this one I want to prioritize? So in this situation, you can see individuals probably outside of their home here and flying a drone over the days in. Um, and then you see right here, here's a commercial airliner. Here's another one coming in. It looks like it's coming in for landing. You've got them all on approach at San Francisco. So this is a part of the picture that will help enable the airspace for more traffic, whether that's introducing drone as a first responder for police, state and local, drone deliveries, more flights of humans. So the relative application to Golden Dome, FAA, Department of Homeland Security, think of this along the southern border, northern border, all the different cities. We set out to make a cost-effective, scalable solution that our USG customers could use, different federal users, state and local, and enterprise commercial for their applications, all on one common operating picture. Now, this data that you see, this is our display, but this data also feeds into others. So that was a key thing, integrating into existing displays and communication systems.
And for, well, let me talk about effector shooter connectivity, because in the one sense, you want to identify the target track as earlier as possible in its trajectory. Then there's the sensor to shooter pairing. What countermeasure is optimal for this particular threat? Whether it's an individual drone, perhaps a kinetic interceptor, perhaps a swarm and might need high powered microwave or EW. How is that next step in terms of information processing and sensor to shooter countermeasure identification transpiring?
Yeah, so it's a lot of things. And the key is having as much information as you can to all of the parties that are the interested parties as fast as possible. So that infrastructure I was just showing you, that's all been live since 2021. So you get a lot of historical data. I'll talk about Arlington PD. They've been one of our longest standing users, an incredible customer, have given us so much different feedback on what they like, what they don't like, evolve quickly. So during game day, if we go to the Dallas Cowboys, we know from monitoring over that whole area in Arlington PD for the last number of years that a drone is most likely going to come out of this parking lot at this time of day before the game when they're about to do kickoff or other things. And the first response in dealing with that situation is getting an officer to the controller as soon as possible. So if we have the controller location, we give it, or we give the point of origin for where it took off. So if the controller is on, we can detect it. If it's not, we have where the drone took off from, and we give that what we call the POO, the point of origin. So when you look at the stages of response and you talk about things like World Cup or big events, your first responder is going to be your state and local. So we want to be able to give them the data and at the same time allow USG and bigger users that have different aspects and different kinetic or non-kinetic countermeasures, they can all work at concert at the same time. For example, when you heard about the drones in New England, we were providing data over Stewart Air Force Base. We were working with our partners at Palantir, feeding into government networks and state and local. We had an individual who decided to fly a drone at night, flew it up over restricted airspace. Base commander got a chirp on his phone and said, "Hey, how are we responding?" State and local was like, "We are inbound." They went and caught the guy within 7 minutes at his door. But if that wasn't going to happen and that drone proceeded to cause more of a threat, we were giving the level of accuracy for the USG customer to then take the next step. Do they want to deploy a non-kinetic measure? Do we ramp it up to a kinetic measure? So the fundamental thing here with what we were trying to do with this was make a cost-effective, scalable solution that can provide the data to everything from your first responder to your final decision.
10-4, one of the Pentagon's favorite words is interfaces and IP protocol. And I can't help but think that different transport layers are going to have different frequencies, different IP protocols. So what kinds of interfaces are you using to essentially enable the networking you just talked about? Because you want to network broader networks with closer in, perhaps local networks, and create that common operating picture.
Yeah, so it's a combination of making our data available both on-prem or over cloud networks, Gov Cloud or on-prem, and then making that available and connected through satellite comlink, cellular, or fiber. Now, different end users will have different levels of capability for different decision making. And the key to doing this was how do we deploy a network that we own that's privacy compliant. And being privacy compliant actually gives us a unique capability of being also non-library based, right? We don't actually have to look at the RF signal, like look in it to pull the GPS location. We triangulate on where the emitter is. Remember, we were talking about earlier, if you're emitting a signal, people know where you are. That's fundamentally how our tech works. If you're emitting a signal, we triangulate on you. If you're not emitting a signal, we use energy in the environment to highlight you with a radar, passive radar. And so with that, you get a full encompass picture of people that are emitting, not emitting, and of all different sizes from small drones to stratospheric balloons, general aviation.
Excellent. Well, on that point, this is the last question. Earlier, we were talking, you mentioned ultralights, and gosh, it spurred my
Yeah.
memory because there was public open source TRADOC intelligence support activity, a portion of TRADOC doing red teaming assessments. And this was as far back as 2007 or 8. They specifically found ultralights as a specific threat. How do you identify something like that? How do you detect and counter a small UAS or a small self-propelling aerial vehicle, perhaps at lower altitude and closer proximity? You mentioned that this has the ability to do that. It's amazing synergy because there was a threat identified years ago, and sure enough, now we have some solutions.
Yeah. So it's all about how do you disperse your sensors and immerse yourself in what we call the clutter. So when you have these energy sources like ASR9s and other radars or weather system, weather radars, comms, we're broadcasting a lot of energy. And that energy is being broadcast down low and up high. The hard part is when you only have one radar or a couple radars, you get issues with discerning a low flying object in a building. But if you have multiple systems deployed and distributed like we do, we have the ability to discern and see those things at low altitude. So we're using energy that is already being broadcast and filling in the areas where we're blind. And that's the fundamental difference, right? When we put those long range radar systems for FAA and other things out there, they were in place for their specific operation. I got planes coming in this areas, they gotta land, they gotta go. But there's a lot of energy that's also being broadcast beyond where they're able to process it and discern a low flying, we were talking about it, a person flying in a shopping cart, or a drone. But with our distributed network of sensors, we use that energy and are able to see those low flying ultralights, drones, and ultimately fill in the picture, which is fundamental as our airspace becomes more complex, right? We want to understand it for safety concerns so we can integrate more things into our airspace and for national security concerns so that we can deal with threats.
10-4. Well, if you were looking for the most recent applications of cutting edge technology in the world of counter drone with potential Golden Dome applications, you came to the right place. You listen to a guy like Mr. Cole. He is the founder and CEO of this cutting edge technology specific to drone. Appreciate your time.
Chris, thank you so much, man. I appreciate it.
Appreciate you. Excellent. Hang on.